Okay, for our weighted average method, including spoilage, let's begin by plotting in our physical units. We were told that we had 1,500 units left over from the prior period. Those, of course, will be our work in process beginning units. So 1,500 physical units there. We also were told that we started 8,500 units in this period. So 1,500 plus 8,500 equals a total of 10,000 physical units that we have got to account for in our process costing form. We were told that we had 7,000 units that were completed and transferred out during the current period. For those under this weighted average method, we are again going to lump the total cost together and lump together the equivalent units numbers that we calculate, and we're basically averaging out our cost per unit as to direct materials and our average cost per unit as to conversion cost. Therefore, those 7,000 units that were completed and transferred out will, of course, be given 100% of their direct materials, because for those work in process beginning units, their direct materials were given to them in the prior period, and for the additional 5,500 units that were completed and transferred out, they too have been given their 100% of direct materials. All of those units have also received their conversion cost as well. So 7,000 times 100% equals 7,000 for direct materials, and 7,000 times 100% conversion equals 7,000 equivalent units as to conversion cost. We were told that we had a remaining 2,000 units in work in process ending. So I'm going to recommend to you guys that you go ahead and plug that number in, because it's going to help us in our calculations in filling out what we would call normal spoilage and what we're going to call abnormal spoilage. So the 2,000 units that are remaining in work in process will have been given 100% of their direct materials as well. So 2,000 times 100% equals 2,000 as to direct materials. We were told that those 2,000 units were only halfway complete. Therefore, their equivalent units in regards to conversion cost is 2,000 times 0.5, which gives us 1,000. Now, we have 10,000 total to account for. We know that 7,000 of those have been completed and transferred out, and that we have 2,000 still remaining in work in process. Therefore, if we take the 10,000 to account for minus 7,000 minus 2,000, that tells us that we have 1,000 units that we have issues with. Alright, so we've got problems, we've got spoilage. Now, if you were to go back and look at the information that was given to you on page 710 or 648, depending on which textbook version you're looking at, they told us that normal spoilage is 10% of goods, 10% of good units transferred out. Okay, so what are we saying? For every 100 or every 10, which I said in the earlier video, for every 100 units that are good units, we expect another 10 on top of that to be normal spoilage. Okay, I said in the other video, out of 10 units, we expect one additional one to be normal spoilage. Same thing, it's all 10%. Alright, so 7,000 was the quantity for our good units. If you take 7,000 and multiply it times 0.10, then you find out that the normal or expected spoilage for 7,000 good units would be 700 units of normal spoilage. Okay, So 700 physical units are considered normal spoilage. We were also told that the direct materials were falling under that same assumption, that they were given 100% of their direct materials, and also that they were looked at as 100% as to conversion costs. So 700 times 100% equals 700 for direct materials and for conversion cost. Now, if you take the 1,000 units that we basically have to account for, that is our total spoilage number. If you take the total spoilage number and you subtract from it the allowed normal spoilage, then you will be calculating the abnormal spoilage. So what is outside of our range? So therein lies our formula. So abnormal spoilage equals actual spoilage, or the total spoilage, minus normal spoilage. So we had 1,000 as to actual spoilage. We calculated out our expected normal spoilage of 700. 1,000 minus 700 leaves us with 300 abnormal spoilage. Abnormal spoilage also received 100% as to direct materials and 100% as to conversion costs. Therefore, 300 times 100% equals 300 equivalent units as to direct materials and as to conversion cost. Again, continuing on with step 2, we still go ahead and tally up our columns. So, 7,000 plus 700 plus 300 plus 2,000 equals 10,000. We have accounted for the total 10,000 units. Direct materials, if you add those up, we have a total of 10,000. In conversion cost, we have a total of 9,000. We can move on to steps 3, 4, and 5, where we're going to go about lumping those costs together and getting our average cost per unit as to direct materials for our equivalent units and our average cost per unit for our conversion cost for our equivalent units. If I can get my computer to work with me here. Alright, in regards to our work in process beginning, we were told in our data set that we had 12,000 in direct materials and 9,000 in conversion cost, which totaled 21,000. And we were also told that for this current period, the month of July, that we had an additional 76,500 and an additional 89,100 in conversion cost, which total up 165,600. If we add all of those together, that's going to be the total amount of cost that we've got to account for and divvy up in regards to their respective areas. Direct materials gave us a total of 88,500. That is our cost incurred to date. And for our conversion cost, a total of 98,100. Notice we're just dropping the numbers down to the next line item. We go back to step 2 and find our equivalent units. For direct materials, we had 10,000 equivalent units. For our conversion cost, we only had 9,000. Taking the total conversion cost to date and the direct materials to date and dividing them by those equivalent units of work done to date gives us our cost per equivalent unit that we're going to use down in step 5. Let's go about assigning the cost out. In regards to the good units completed and transferred out, we've got 7,000 total units. We have costs before adding anything to do with the normal spoilage, because recall what I said in one of our prior videos, that typically what we're going to be doing is absorbing into our cost per unit for our good units the cost of those normal spoilage units. Alright, so we had 7,000 equivalent units of direct materials and 7,000 equivalent units as to conversion cost for those 7,000 units completed and transferred out if you were to go back and look at step 2. So 7,000 times 885 equals a number that we could put in that box, and 7,000 times 1090 also equals a number that we could put into that box. If we add those two numbers together, we would get 138,250. Now we're going to calculate the normal spoilage so that we can put that number or that value into our good units. So if we were to go back and look at step 2, we calculated out 700 equivalent units as to direct materials and also as to conversion cost based on our assumptions of 100% on both. 700 times 885 and 700 times 1090, both of those equal numbers that we could place in those cells. Adding those two together gives us 13,825. If we take the 13,825 for the normal spoilage cost and add it to our 7,000 good units cost of 138,250, we get a total number of 152,075. And that's the number that we would move from this work in process account either into another work in process account or into finished goods inventory, depending on what we're doing at our facility. All right, then we had the abnormal spoilage. They have a cost. And again, we're wanting to use our management by exception. We have got to highlight the fact that process isn't working so great and we have got some problems and we need to figure out what is going on. So 300 units at 100% as to direct materials and also as to conversion cost gave us equivalent units of 300 and 300. Therefore, 300 times 885 equals a number, and 300 times 1090 equals a number. Filling those two cells in and then adding them together, we have $5,925 as to our abnormal spoilage. We would want to bring that to someone's attention and try to figure out what we could do to eliminate that problem going forward. And lastly, we still have the work in process inventory, and we're going to do it just like we've seen in Chapter 17. We've got 2,000 units. 2,000 units at 100% as to direct materials, so 2,000 times 885 equals a number that we would put in that cell. And those 2,000 units were only 50% converted, giving us an equivalent units total of 1,000. 1,000 times that cost per equivalent unit of 1090 would give us a number, and if we add those two together, we would have the remaining work in process ending balance of 28,600. If we were to go and total up all of our cost, the 152,075 plus 5925 plus 28,600 tells us we've got $186,600 total cost accounted for. We can also, of course, check this way to make sure that these two numbers equal it as well, and then make sure we are matching with our total cost to account for. Might I add that you guys need to double check your numbers, because on test 3, the problem has to be done completely correct, or your answers all throughout it will be incorrect. All right? So double check all of your math and make sure you're plotting things in where they need to go. Might I add at this time that managers have found that improved quality and intolerance for high spoilage have lowered overall cost and increased sales. Okay, so if we're producing better quality products, then our customers are going to love that added value, and they are going to be willing to not only pay us for it, but spread the word, and hopefully their friends and family are going to buy the products as well, which all, of course, leads to increased sales. So we like improving our quality, and having an intolerance for our spoilage is going to help us do that. I will pause now and move us over to the FIFO video next.